Welcome back from the ad break, and let's continue with our lesson. Now we are going to look at that first concept in our concept map, which is that fifth exponent law, and that is raising a power to an exponent 0. So let's see how we can work with that. So powers raised to an exponent 0. If we have 3 exponent 5 divided by 3 exponent 5. Now we have to remember those exponent laws that we've already learned about. And when we are dividing powers that have the same base, do you remember what happens? Well, firstly, if we say 3 exponent 5 divided by 3 exponent 5. Remember, we are going to expand each of those each of those powers. So that is 3 times 3 times 3 times 3 times 3. And that is divided by again 3 multiplied by itself 4 times. Now remember, when we are dividing a number by itself, it will give us 1. So that means that that fraction there will give us a 1. We're multiplying it by 1, multiplying it by 1, multiplying it by 1, and again multiplying it by another 1. Now 1 multiplied by 1 multiplied by 1 multiplied by 1 and multiplied by 1 again will give us an answer of 1. So from this 3 exponent 5 divided by 3 exponent 5, we get an answer of 1. But of course, we already knew that because according to the properties of 1, when you divide a number by itself, the answer is going to be 1. But what about our exponent laws that we learned before? Now, according to the rule of dividing powers of the same base, 3 exponent 5 divided by 3 exponent 5 is equals to 3, and in the exponent there, we are going to subtract those exponents, that is 5 minus 5. And that gives us 3 exponent 0. So now, what do we have here? We have 3 exponent 5 divided by 3 exponent 5 is equals to 1, according to the properties of 1. Again, we have 3 exponent 5 divided by 3 exponent 5 is equals to 3 exponent 0. Now, this is according to that second law of exponents of when we are dividing powers of the same base. Now, from these two statements, what can we conclude? Since as well 3 exponent 5 divided by 3 exponent 5 is the same as 3 exponent 5 divided by 3 exponent 5, we can therefore conclude that what they are equals to, meaning this one and this 3 exponent 0, we can conclude that they are equal to each other. That means that 3 exponent 0 is equals to 1. Now, will this be the case all the time? Let's check. If we have a p exponent 3 divided by a p exponent 3, now when we expand each of these powers, we know that p exponent 3 means p is multiplied by itself twice. Now that is the case in the numerators as well as the denominators. Now when we divide these two powers, we can see that that is 1 multiplied by 1 multiplied by 1 again, and we know that that is going to give us an answer of 1. Now, where does that 1 come from? If we go back to that second law of exponents, then we know that if the base is the same, then we are going to subtract the exponents. So that is exactly what we did there, and we had p exponent 3 minus 3, which is p exponent 0. But as we can see, according to our equation there, that our p exponent 0 is equals to our 1. So in summary, when we are talking about powers raised to an exponent 0, we can say that if a number is raised to an exponent 0, then the answer is 1. Let's look at the following calculations and see if this is true, or see how we can apply this law within our calculations. Let's calculate the following. Now we have been given 3 exponent 0, and now since as well we saw that a number raised to the exponent 0 will be equals to, well, if you are thinking of 1, then you are absolutely correct. Then if we are looking at this next one here, we can see that we have a negative 2 exponent 5, and this is now raised to the exponent 0. Now, we know that this whole power is raised to the exponent 0. So if it's raised to the exponent 0, we can just say that our answer is a 1. But of course, if we want to use the other laws of exponents to calculate this, we can also say there that because this is a power being raised to an exponent, yes, a power being raised to the exponent, we know that the two exponents will multiply with each other. So this will make it a negative 2. So this will make it a negative 2, and we have there a 5 multiplied by a 0. This will make it a negative 2, and 5 multiplied by 0 is a 0, which again, because we have a number that is raised to the exponent 0, our answer will be a 1. So let's look at the following questions and let's try and answer them without the use of a calculator. The first question there says 7 exponent 0. Now we know that a number raised to the exponent 0 will be 1, and we know that that answer there is 1. What about the next one of a negative 3 squared raised to the exponent 0? Now this is a power raised to the exponent 0, but of course we know that that whole power will become 1. Why? Because anything raised to the exponent 0 will be a 1, just like we did in that previous example. What about when a product is raised to the exponent 0? Well, let us see. So now we have there a negative 9 multiplied by a negative 2. And they are raised to the exponent 0. Now, there are quite a few ways that we can calculate this, but we will only choose one of those ways. Let us apply our exponent laws here. We know that the negative 9 has an exponent 1 and the negative 2 has an exponent 1. So now we have a negative 9 and we have an exponent 1 multiplied by 0 because that exponent has been raised to this product. So each exponent within the product must be multiplied with the raised exponent. Then we are multiplying this by a negative 2 and we have 1 multiplied by 0. Now this will lead us to a negative 9 exponent 0 multiplied by a negative 2 exponent 0. Of course, this will give us a 1 multiplied by a 1, and in the end, our answer is going to be a 1. So we could have just said this whole product is raised to exponent 0 and our answer is 1, but just to prove that this is true, we can see that we still maintain the answer of that 1. Then that next one there, we have 6 exponent 6. This is raised to the exponent 0, of course, because everything is raised to the exponent 0, we know that our answer there will be a 1. Now let's move on to the second part or the second concept in our concept map, and that is scientific notation. So now that we've learned all our exponent laws, we can apply also these laws within scientific notation. So what is scientific notation? Scientific notation is a way of writing numbers that are too big or too small to be written clearly in decimal form. Now, for example, we have 150 million. That is written as 1,5 multiplied by 10 exponent 8. So scientific notation is written as a decimal that is multiplied by a power of 10. As we can see in our example, we have a decimal there and it is multiplied by a power of 10. Let's learn more on how we can do this and what is needed for us to write numbers successfully in scientific notation. Well, to write a number in scientific notation, it must be, firstly, written as a product of two numbers. So it needs to be a product, which means we multiply, of two numbers, right? Then secondly, it needs to be written in the form a multiplied by 10 exponent n, where a is a decimal. Remember we said that it is a product of between a decimal, and where n is an integer, and as we can see, n is an exponent to the 10. So remember we said scientific notation, it is a decimal that is multiplied by a power of 10. Then thirdly, we need to make sure that the decimal is between 1 and 10. So the decimal needs to be between 1 and 10. Let's look at this example here. So here we are given 8,130,000 and we are supposed to write it in scientific notation. Now keep in mind those 3 points that we have to keep in mind. So we are required to write the 8,130,000 in scientific notation. Now remember those 3 points. Well, one of the points said that the decimal must be between 1 and 10. So one thing we know for sure is that our number that is in scientific notation is going to start with an 8, and we are going to make it a decimal, making sure that it is less than 10 but more than 1. So that means we are going to take these numbers that we see here, but making sure that they are a decimal. So it needs to be 8,13. Now, according to our another point, it needs to be now that decimal that we chose, and we are going to multiply it by a power of 10. So we are going to multiply it by a power of 10. And that 10 now needs to have a certain exponent. But let's see how we can figure out what that integer needs to be. So again, remember those 3 points. And as we have stated in the beginning, we had 8,13. So we know our decimal is going to be 8,13. But how do we find out how many tens, since as well it needs to be multiplied by a power of 10, we need to find out how many tens are multiplied to this 8,13 so that it gives us that 8,130,000. So when we multiply it by the first 10, we get 81,13. We multiply that 81,13 by 10 again, and then we are given an answer of 813. Now we're going to take that 813 and we are going to multiply it by 10, and that is going to give us an answer of 8,130. Now keep in mind we've already multiplied by 1, 2, 3 tens for us to get to 8,130. So then we are going to multiply that 8,130 by 10 again, and that is going to give us 81,300. We continue multiplying by 10 because we haven't reached our value yet. So 81,300 multiplied by 10 gives us 813,000. Then we multiply by 10 again, and then we finally get to our 8,130,000. Now, how many tens did we multiply? So from that decimal value that we had to get to our 8,130,000, well, we took that 8,13 and we multiplied it by 1, 2, 3, 4, 5, and 6 tens. And as we can see there, 1, 2, 3, 4, 5, 6. And what does the first exponent law say about us multiplying powers that have the same base? That means we can add those exponents. So that means that it is going to be 8,13 multiplied by 10 exponent 6, only because we multiplied by 6 of those tens. And that now gives us the original value that we were given, which is 8,130,000. Let's quickly go to an ad break and then we'll continue with our lesson.